difference between open interval and closed interval. This is the definitions of open interval and closed interval. Previous week we completed this one. Okay, today we can start a 2.1.1 definition. Okay, this is the neighborhood definition. What today? Neighborhood definition. How many members are came here? Only 4 members. My voice is clear, all of you? Hello? My voice is clear? All of you, my voice is clear? Okay. I can start the definition. If A belongs to R, see the page number 23. Here the definition A belongs to R. Means A is a number in a real number. A is a number in capital R. Capital R means real number set. And epsilon is greater than 0. You can take a positive number, epsilon. Epsilon greater than 0 means to take a positive. Okay, is a real number. Okay, epsilon greater than 0 is also a real number. Then the set x such that x belongs to R. Modulus of x minus a is less than epsilon is called the epsilon neighborhood of A. Epsilon neighborhood of A. How it is possible means here I am taking here mod x minus a is less than epsilon. This is the first step. I am taking mod x minus a less than epsilon. Mod is giving plus positive number and negative number. Here negative number is taking left side. Positive number take right side. Here minus epsilon less than x minus a less than epsilon. Okay, this is the inequality by adding a on left hand side. A no left side నుంచి మనం యాడ్ చేసుకుంటూ వెళ్దాం. A minus epsilon less than a plus x minus a less than a plus epsilon. A అనేది మనం లెఫ్ట్ సైడ్ ఈ ఇన్ఈక్వాలిటీలో మనం సబ్స్టిట్యూట్ చేస్తాం. యాడ్ చేసుకుంటూ వెళ్దాం. ఇప్పుడు ఇక్కడ ప్లస్ a minus a క్యాన్సిల్ అయింది అనుకోండి. మనకి ఎంత మిగులుతుంది? We will get here a minus epsilon less than epsilon less than x less than a plus epsilon. It means x is belongs to a minus epsilon comma a plus epsilon. Means here suppose x is a number. Left neighborhoods are a minus epsilon and the right neighborhoods are a plus epsilon. Okay, this is total. It is called mod x minus a less than epsilon. Mod x minus a less than epsilon. The definition, I am again reading the definition. If a belongs to R and epsilon is greater than 0 is a real number, then the set x such that x belongs to R mod x minus a less than epsilon is called the epsilon neighborhood of A. Epsilon neighborhood of A. This is the a minus epsilon is epsilon. A minus epsilon in the number line. X is a number, a real number. A minus epsilon. A minus epsilon is left neighborhoods of x and a plus epsilon is right neighborhoods of x. The total set x belongs to a minus epsilon comma a plus epsilon is the epsilon neighborhood of A. Here, where is A? A అనేది ఎక్కడ ఉంది మరి? Here, to take here. To take here. Here suppose it is the x, this is the a. Okay, it is also minus a. Okay, here minus a and plus a. It will give here minus a and plus a. Here x neighborhoods. A neighborhoods are what here? Left neighborhood of x and right neighborhood of a. Okay, this is the definition of neighborhood. Next one, notation, neighborhood notation. Here neighborhood definition and neighborhood spelling is what here? NEIGHBORHOOD. Here n is capital. To take n is capital and a is the neighborhood of a and epsilon. Okay, n is epsilon neighborhood of a. N means a neighborhood. Here epsilon neighborhood of a. read it as epsilon neighborhood of A. దీన్ని ఏ విధంగా చదువుతాము? ఎప్సిలాన్ ఫస్ట్ మనం చదవాలి. ఎప్సిలాన్ తర్వాత ఎన్ అంటే నేబర్హుడ్, ఇక్కడ బ్రాకెట్ ఆఫ్ అంటాము, తర్వాత ఏ అంటాం. ఓకేనా? ఇట్లయినా చదవచ్చు. ఇట్లా కొంచెం కష్టం అనిపిస్తే ఎన్ ఆఫ్ ఎప్సిలాన్ కామా ఏ అని చదవచ్చు. ఎప్సిలాన్ ఫస్ట్ ఎప్సిలాన్ నేబర్హుడ్ ఆఫ్ ఏ అని చదవాలి. దిస్ ఈస్ ద నొటేషన్ ఆఫ్ ద నేబర్హుడ్. ఓకే, నేబర్హుడ్ లో మీరు గుర్తుపెట్టుకోవాల్సింది ఏమిటి? హియర్ ఎక్స్ ఈస్ ద ఇంటీరియర్ పాయింట్. ఎక్స్ అనేది మనకు ఇంటీరియర్ పాయింట్ లాగా ఉంటుందని మనకి ఇక్కడ కనబడుతుంది. ఎక్స్ బిలాంగ్స్ టు ఏ మైనస్ ఎప్సిలాన్ కామా ఏ ప్లస్ ఎప్సిలాన్ మధ్యలో ఎక్స్ వాల్యూస్ అనేటివి మనకు ఉంటాయి. ఎక్స్ కు ఎడమ వైపు నేబర్హుడ్స్ ఉంటాయి, ఎక్స్ కు కుడి వైపు నేబర్హుడ్స్ ఉంటాయి అని ఇక్కడ మీరు గుర్తుపెట్టుకోండి. ఎక్స్ అనేది ఇంటీరియర్ గా ఉంటుంది అనేది ఇక్కడ బాగా గుర్తుపెట్టుకోవాలి. నెక్స్ట్ మనం ఇది అర్థం కాకపోతే ఎక్స్ మైనస్ 2 లెస్ దెన్ 1/4 అనేది తీసుకోండి. ఏమని తీసుకుంటున్నాం ఇక్కడ? ఎక్స్ మైనస్ 2 లెస్ దెన్ 1/4. హియర్ రిమూవ్ ద mod. Here remove the mod. We will get here minus 1/4 left hand side and plus 1/4 is right hand side. X minus 2 is in middle. Therefore, how much the inequality? Minus 1/4 less than x minus 2 less than 1/4. Adding 2 on left hand side. Adding 2 on left hand side by the above inequality. 2 minus 1/4 less than x minus 2 plus 2 less than 2 plus 1/4. Okay. Here 2 minus 4, 2 cancel here. 2 minus 1/4 less than x less than 2 plus 1/4. Here x is belongs to 2 minus 1/4 comma 2 plus 1/4. Here it is called as what here? 1/4 neighborhood of 2. 1/4 neighborhood of 2. 2 కు neighborhoods ఏముంటాయి? లెఫ్ట్ సైడ్ లో minus 1/4 కి సంబంధించిన 2 minus 1/4 neighborhoods ఉంటాయి. 2 కు రైట్ సైడ్ లో 2 plus 1/4 neighborhoods ఉంటాయి. ఓకేనా? హియర్ I am drawing here 2. Here 2 minus 1/4 neighborhoods. Okay. Here 2 plus 1/4 neighborhoods. Okay. 2 minus 1/4 neighborhoods and 2 plus 1/4 neighborhoods. Okay. This is the definition and example of a neighborhood. ఇది అర్థమైందమ్మా? ఏమైనా డౌట్స్ ఉన్నాయా? All of you. అర్థమైందమ్మా? ఏమైనా అర్థం కాని ఏమైనా ఉందా? హలో, నెక్స్ట్ పేజ్ ఓపెన్ చేస్తున్నా. ఐఎమ్ ఓపెనింగ్ నెక్స్ట్ పేజ్. Here the second page. Here the definition of interior point. Next definition of interior point here. Let A subscript is equal to R and A belongs to A. If there exists a real number epsilon greater than 0 such that the epsilon neighborhood of A is contained in A, then the point A is called an interior point of A. Interior point of A. We are taking what here? Small a belongs to capital A. Here capital A is where here? It is subscript is equal to real number set. Subscript is equal to real number set. It means A is belongs to A and A is also belongs to R. A అనేది capital A లో ఉంటుంది, A అనేది capital R లో ఉంటుంది. There exists a real number. రియల్ నెంబర్ ఎంత తీసుకుంటున్నాం? రియల్ నెంబర్ సెట్ ఎగ్జిస్ట్ కావాలంటే మనం ఏం తీసుకుంటున్నాము? ఎప్సిలాన్ ఈజ్ గ్రేటర్ దాన్ 0. 0 కంటే కొంచెం ఎక్కువ విలువ తీసుకున్నాం అనుకోండి, ఆ రియల్ నెంబర్ అనేది ఎగ్జిస్ట్ అయినట్టుగా మనం చెప్తాం. సచ్ దట్ ద ఎప్సిలాన్ neighborhood of A. ఎప్సిలాన్ neighborhood of A means n epsilon of A. ఈ విధంగా తీసుకోవచ్చు. You can take here n of epsilon comma A. Okay. Here also same. Here to take this one, neighborhood of A. Epsilon neighborhood of A is contained in A. Is contained in A. It is contained in A. ఇది ఎక్కడ ఉంటుంది? A లో ఉంటుంది, క్యాపిటల్ A లో ఉంటుంది అని చెప్తున్నాడు. Then the point small a is called. Then the point small a is called an interior point of A. Interior point of A. Okay. I am again explaining the interior point. Suppose you can take a set. Suppose here this is the capital A, the set. Small a is an element. Okay, it is a number line. Okay, here left side numbers is what here? X minus a, neighborhoods, and right side means x plus a, neighborhoods. Okay, here a is interior point. A is interior point of here. A is interior point of capital A. ఈ విధంగానే ఉండొచ్చు. A అనేది ఈ విధంగా తీసుకోవచ్చు. ఓకేనా? A subset is equal to R number. Okay, this is the A is interior point. A is interior point of A. Next one, if A subset is equal to R and if every A belongs to A is an interior point of A, then capital A is called an open subset of R. Here R is the set, R is the set, and A is the subset. A is the subset. Okay, now here interior point small a is belongs to A. Small a is the interior point. Interior point. This is interior point. Here capital A is called what here? Open subset. Open subset. What is R here? Set. R means the set. A means open subset. A is small a is interior point. Okay, now this is the inner meaning of the above lines. Next one, an open interval, an open interval small a comma b is an open set. A comma b belongs to R. For every x belongs to A comma b, there exists delta greater than 0 such that x minus delta comma x plus delta is subset is equal to A comma b subset is equal to R. Okay, here x minus delta is A and x plus delta is a B. You can take here. Okay, now open interval is what here? A comma b, and open set is what here? A comma b, and A comma b is real numbers, two real numbers. For every x belongs to A comma b means x is the interior point of A comma b. X is the interior point of A comma b. Open interval. X is the interior point of A comma b. There exists a small number delta greater than 0. Delta greater than 0 means it is a positive number, real number, such that x minus delta comma x plus delta is substar is equal to A comma b, substar is equal to R. Okay, this is the definition of interior point and open subset and open interval. Three definitions and example here. R and phi are open sets in capital R. Phi is empty. Phi means it is empty set. Empty set means there is no number, and capital R means here real number. Real numbers is an open sets in capital R. These two are open sets. Open sets in R. Open sets in R. Suppose you can take a number x belongs to R. X belongs to R means R is the set, x is the interior point. X is the interior point. Therefore, you can take here x belongs to R. It is the interior point. It is having a neighborhood on left hand side is x minus epsilon, and right hand side having right neighborhoods, that is x plus epsilon. Okay, it is open interval. Why? Because it is interior point. It is interior point. It is having a open interval. It is subset is equal to R for any epsilon greater than 0. For any epsilon greater than 0. Here epsilon means it is a positive real number subtracting from x and adding from x. Therefore, we are taking a positive real number epsilon greater than 0. We are subtracting x minus epsilon and adding x plus epsilon on left and right neighborhoods of x. Okay, now this is the open sets. What is the open sets here? Phi and capital R is the open sets. Okay, this is the one point, one example. Phi is empty because it contains not points. Phi is empty. Phi is empty because it has no points. Because it has no points. Why? Because it is empty. It satisfies the definition of open sets. Okay, now this is the 2.2 definition. Okay, any doubts in this page? Any doubts in this page? No doubts? Okay, next page I am opening. Second page completed. Next one, third page. I'm opening third page. Here 2.2.11. Here 2.2.11 theorem. The intersection of two open sets is an open set. Here the page number. Here the page number is 25. See the page number 25. I am explaining the intersection of two open sets. Two open sets is an open set. Intersection of two open sets is an open set. Here we are assuming proof A and B be two open sets. A and B be two open sets. A is the open set and B is the open set. It is belongs to A comma B belongs to what? Where it is real numbers. Real number sets. Okay, na? A is the real number set and B A is a subset of R and B is a subset of R. Here this A comma B are two open sets in R. Open sets means it having interior points. It having interior points. Suppose we are taking intersection here. We are taking intersection. Intersection means common points. Okay, na? A intersection means B means it is having a common point, that is X. Okay, A and B. Okay, here X is belongs to where A intersection of B. Here suppose here by the definition of open set neighborhood, here first of all we are taking X belongs to A. X belongs to A. We can define by the neighborhood definition of open set. X belongs to A, comma A is open set. Okay, here to take a positive real number epsilon greater than 0 such that the neighborhoods of X is what here? Epsilon 1 comma X is subset A. Is a subset A. This is the definition. Similarly, you can take X is belongs to B and B is open set. You can take B is open set and X belongs here epsilon 2. You can take epsilon 2 greater than 0. Why? Because B is open set, another open set. Therefore, to take one more real number epsilon 2 greater than 0 and the neighborhood definition is what here? N means neighborhood. Epsilon 2 is the real number and X is a number between left neighborhoods and right neighborhoods. Therefore, you can write here n of epsilon 2 comma X subset to B. Here to take here epsilon is equal to here minimum of epsilon 1 comma epsilon 2. To take minimum of epsilon 1 comma epsilon 2, that is epsilon. Therefore, the new definition came here. Neighborhood of X is the minimum point is n of epsilon comma X. Okay, to take here epsilon is greater than 0. The X value is a common point of A intersection B. The X is the interior point of A and B. Therefore, it means that any X belongs to A intersection B is an interior point of A intersection B. Thus, A intersection B is an open set. A intersection B is an open set of the theorem 2.2.11. Okay, this is the first one. And next one, to take the union of collection of open sets. Union of collection of open set. This is the second one. The union of the second one is we are underlining page number 25. You can see the union of any collection of open sets is an open set. The union of any collection of open sets is an open set. Okay. Open sets having interior points. Open sets having interior points and it containing open interval. It containing open interval also. Here we are taking collection of open sets. Collection of open sets in next page. Okay, here any doubts in this one? Next page I am opening. Okay, let B be the collection of open sets here. B be the collection of open sets. We are taking collection of open sets. Here, then consider X is equal to union. Union means it is collection of open sets. Here, A is belongs to B. A is belongs to B. B is the collection of open sets means it is the notation is X is equal to union set of A such that where A is belongs to B. Okay. Here, suppose to take here a point X. To take a point X, the point is in B. In B means it means here to take X here. To take X here means it is a B. Okay. Here X is belongs to A first of all. Next one X is belongs to B. X is belongs to A, and next one X is belongs to B. Okay. Here we are taking X is belongs to means the X point is in B. Okay. And the X point is in A. A is the subset of B. A is the subset of B. A is the subset of B means here what here? A is a open set. B is also a open set. Remaining is there 1, 2. Here this is the 1, 2, 3. This is three. These three open sets is collection of open sets. These three sets are collection of open sets. Okay. There exists an open set X belongs to B with X belongs to A. There exists to take a real number. Why? Because X having left neighborhoods and X having right neighborhoods. Therefore, we can take a real number epsilon greater than 0 and such that the neighborhood notation is n of epsilon comma x. It is a subset is equal to A. It is subset is equal to A. It is subset is equal to A means the total collection is where here? It is in X. It is in X. Therefore, the X neighborhood means it is n of epsilon comma x is subset to X. Subset to X. Actually, it is subset to A. But the X is also an open set. It is open interior point in A. It is also is in X. Therefore, hence X is open. Why? Because X is the collection of open sets. Therefore, small x is belongs to A and small x is belongs to B and the neighborhoods of X is subset to capital X. Therefore, hence capital X is open. Capital X is here open. This is the theorem. Next one. You have any doubts in this one? Any doubts in this one? No doubts? Okay, next page. Next, one more theorem here. One more theorem. The page number here, page number 27. Page number 27. Here, the union of two closed sets is a closed set. Closed set means it is suppose A is a real number and B is a real number. A and B are numbers in real number set. Okay. Here closed set means A is included and B is included and the remaining interior parts also in between A and B. This is the closed set. Okay. This is the closed set. Here proof of first one is the question is the union of two closed sets is a closed set. The union of two closed sets is a closed sets. Closed set means Here A is included and B is included. Okay, lies on the interval, lies on the interval, or lies on the curve, lies on the curve. The points A comma B is lies on the curve. We are taking A and B included in the interval. A comma B are included in the interval is called the closed set. Here we are taking two closed sets. Okay, two closed sets. That is B1 is the first closed set and B2 is the second closed set. Okay, here we are taking complement. B1 complement. B1 complement means B1 is the closed set. Complement means it is not a closed set. B1 complement. B1 power C. B1 power C means B1 is complement means it is open set. B1 is closed set. B1 complement is open set. You can write down R minus B1. Okay. And again, B2 complement. B2 complement means B2 is closed set. B2 complement is open set. Okay. You can write down here R minus B2 are open. You are taking here B1 complement intersection B2 complement is an open set. Is an open set. You can take, we want to prove closed set. We want to prove here closed set. You can take here B1 complement. It is implies to B1 complement intersection B2 complement or whole complement. Whole complement. We will get how much it is? B1 complement whole complement union B2 complement whole complement is equal how much it is? B1 union B2. B1 union B2. This is the theorem 2.2.15, page number 27. The union of two closed sets is a closed set proof. This is one, a small proof by given in the textbook. Okay. Next one, the intersection of any collection. Second one, the intersection of second one. The intersection of any collection of closed sets is a closed set. Okay. First of all, let A be a collection of closed sets. Then collection of means it is union. Collection means it is union, to take union. Okay, na? Here to take here B complement. Complement means open. Without complement means closed set. We are assuming first of all open set and last we are proving closed set. Okay. Here B complement means it is open set. Here union is there before. Union means collection of open sets. It is B belongs to capital A means it is equal to R minus intersection of set of B such that B belongs to A is open. Here subtracting from real numbers. Subtracting from real numbers of open sets. R is the real number. It is the open set numbers. Okay, subtracting these two. We will get how much it is? Open numbers only. We will get how much it is? It is open. Hence, to take here intersection of B such that B belongs to A is a closed set. Intersection of B such that B belongs to A. Here, B means closed set. B means closed set. B complement means open set. B complement means open set. Here it is what here? It is a closed. Means here real numbers minus closed set numbers. Real numbers minus closed set. Which type of closed sets here? Intersection. Collection of closed sets. Intersection of collection of closed sets. It is giving open numbers only. Okay, now hence intersection of a set of B such that B belongs to A is a closed set. Okay, this is the unit 2 two theorems. Okay, next I am entering into page number 34, unit 3, real sequences and convergency. Real sequences and convergency. Next I will explain two more theorems on tomorrow class of open intervals. Okay, we have total important 6 theorems is there. I explained today definition of neighborhood, and what type of neighborhoods are there, and I am given example, and two theorems, collection of open intervals is uh, collection of closed sets is a closed set, and collection of open intervals is an open set. Okay, na? These two theorems are completed. Tomorrow I will explain two more theorems in unit 2. Now I will start unit 3, real sequences and convergency. Okay. Next page I am opening. It is very important one. Real sequences and convergency. Real sequences and convergency. Here the page number here the 35, 3.2.1 definition. 3.2.1 definition is there here. 3.2.1 definition. You can see in textbook. The first line is a sequence is a set of natural numbers. Set of numbers presented in an order, starting with a first, second, third, etc. in given textbook. Given textbook definition is what here? A sequence is a set of numbers presented in an order, starting with the first number, comma, second number, comma, third number. Here we are writing in order. We are writing in order. First lowest number, next highest number, next highest number, next highest number, and so on. We are writing in a order, increasing order or decreasing order. Any order we can maintain in an order. It is called as a sequence. Okay. One more sequence is there here. Definition. Here I am written a sequence in S. Sequence means spelling is SEQUENCE. The first letter is S. The first letter is S. Sequence is denoted by capital S. Okay. Here the sequence is a function. The sequence is a function. Okay. We can see in later how many types of sequences is given in example problems. Okay. A sequence in S. Sequence means S is a function defined from capital N to S. Capital N means natural numbers. Natural numbers. S is the sequence. S is the sequence or range of numbers. Range of numbers. Here range of numbers is what we can take here, capital R. Range of numbers is what here? Capital R. Means the sequence is defined from N to R. Here R means S. Okay. Are you understand? Sequence అనేది natural numbers నుంచి రియల్ numbers అనేటివి డిఫైన్డ్ చేయడం జరిగింది అని ఇక్కడ మనం డెఫినేషన్ చెప్తున్నాము. ఓకేనా? ఇక్కడ మనము నెంబర్స్ ఏ విధంగా రాస్తున్నాము? సీరియల్ ఆర్డర్ లో ఇంక్రీజింగ్ ఆర్డర్ లోనైనా రాయొచ్చు, లేదా డిక్రీజింగ్ ఆర్డర్ లోనైనా రాయొచ్చు. ఆ విధంగా రాయడాన్ని మనము సీక్వెన్స్ అని అంటాము. ఓకే. ఏ సీక్వెన్స్ ఇన్ అగైన్ ఐ ఆమ్ డిఫైనింగ్ a sequence in S is a function defined from natural numbers to real numbers S. Okay, real numbers S. Here x1 comma x2 comma x3 and so on, xn and so on. This is the sequence order. R S is a function means you can denote by function notation also. F of 1 comma f of 2 comma f of 3 comma f of 4 and so on, f of n and so on. అంటే ఇక్కడ మన ఫంక్షన్ కూడా సీక్వెన్స్ లో ఉంది అని చెప్తున్నాం. x1 తోనైనా చెప్పొచ్చు, x2 x3 తోనైనా చెప్పొచ్చు, f1 f2 f3 తోనైనా మనం చెప్పొచ్చు. We write the sequence as curly braces xn or open bracket xn. Xn is denoted by curly braces of xn or open interval of xn. ఈ విధంగా చెప్పొచ్చు. Okay, this is the first definition of the sequence. Next one, 3.2.2 definition. If sequence here, first of all, to here you must speak the sequence. Curly braces ఏమని చదవాలి మనం? ఫస్ట్ సీక్వెన్స్ అని చదివిన తర్వాతనే xn అని చదవాలి. ఓకేనా? యు మస్ట్ స్పీక్ సీక్వెన్స్ xn. దీన్ని ఏమని చదవాలి? సీక్వెన్స్ xn అనే చదవాలి. ఓకేనా? అందుకని రాస్తున్నాను. ఇఫ్ సీక్వెన్స్ xn here xn is a sequence and ఎట్లా ఉంటుంది దీంట్లో నెంబర్స్ అన్ని r1 less than r2 less than r3 less than and so on rn. It is increasing. It is increasing order. Which type of increasing order? Strictly less than ఉంది. Less than or is equal to increasing order. Increasing natural numbers అంట. ఓకేనా? మరి ఇవి ఎట్లున్నాయి? లెస్ దెన్ ఆర్ ఈజ్ ఈక్వల్ టు లేవు, లెస్ దెన్ ఉన్నాయి కాబట్టి స్ట్రిక్ట్లీ అన్నారు. ఏమన్నది మనం? స్ట్రిక్ట్లీ ఇంక్రీజింగ్ న్యాచురల్ నెంబర్స్. దిస్ ఈజ్ ద స్ట్రిక్ట్లీ ఇంక్రీజింగ్ న్యాచురల్ నెంబర్స్. అంటే సీక్వెన్స్ అనేది ఈ విధంగా ఉంటుందని చెప్తున్నాను. ఇంకొక సీక్వెన్స్ కూడా తీసుకుంటాను. వన్ మోర్ సీక్వెన్స్ ఇస్ దర్. సీక్వెన్స్ XRN. సీక్వెన్స్ XRN is equal to XR1, XR2 and so on is called a subsequence of sequence XN. XR1, XR2 ఏమనొచ్చట? సబ్సీక్వెన్స్ అని అనొచ్చట. ఏ విధంగా అంటామో మనం నెక్స్ట్ చూద్దాం. ఏ సీక్వెన్స్ హ్యావ్ సెవరల్ సబ్సీక్వెన్సెస్. అంటే ఎన్నైనా సబ్సీక్వెన్సెస్ ఉన్నాయి. ఒక సీక్వెన్స్ లో ఎన్ని సబ్సీక్వెన్సెస్ అయినా ఉండొచ్చు అని చెప్తున్నారు. ఇదంతా కూడా ఇంక్రీజింగ్ ఆర్డర్ లో ఉందా, డిక్రీజింగ్ ఆర్డర్ లో ఉందా? నెక్స్ట్ వన్ సబ్సీక్వెన్స్ ఏ విధంగా రాస్తున్నాడు, సెవరల్ సబ్సీక్వెన్సెస్ ఏ విధంగా ఉన్నాయి నెక్స్ట్ పేజ్ లో ఎగ్జాంపుల్ ఉంది. ఆ ఎగ్జాంపుల్ బట్టి మీరు అర్థం చేసుకోవచ్చు. ఓకేనా? ఐఎమ్ ఓపెనింగ్ నెక్స్ట్ పేజ్. Okay, here 3.2.4 example. 3.2.4 example. Here, first of all, I am taking here letter xn is equal to small n. Xn is equal to what here? Small n. This is the sequence. Then the sequence xn. అంటే here xn ఏమనొచ్చు మనం? Sequence అనొచ్చు. xn denoted by curly braces of xn. xn is equal to how much here? 1, 2, 3, 4, 5 and so on n. It is increasing order. It is increasing order. 1, 2, 3, 4, 5 and so on. Consider a subsequence x2n. Because subsequence తీసుకోవచ్చు మనం. x2n తీసుకుంటే ఏమైంది? 2 టేబుల్. ఎక్కువ 2, 4, 6, 8 and so on 2n. Okay. This is a subsequence. To take a 3 table also. Okay. x3n is equal to how much? Here 3, 6, 9, 12 and so on is a subsequence. And to take x4n, x4n is equal to how much? 4, 8, 12, 16 and so on infinite terms. To take x5n is equal to how much? 5, 10, 15, 20 and 25 and so on. These are all subsequences. x2n, x3n, x4n, x5n, x6n. These are all subsequences. How many subsequences? Several subsequences. Here only xn is equal to n is the sequence. xn is equal to n is the sequence. x2n, x3n, x4n, x5n. These are all subsequences. Okay. Next one 3.2.5 example. Subsequences, sequence అంటే మీకు అక్కడ అర్థం కాకపోతే one more example is there. 3.2.5. 3.2.5. Okay. Here consider the sequence here. 1, -1, 1, -1 and so on. It can be written as xn is equal to -1 whole to the power of n minus 1. -1 whole to the power of n minus 1. You can take here n is equal to 1. N is equal to 1 means how much? 1 minus 1 is equal to 0. -1 whole to the power of 0 is equal to 1. Next one, n is equal to 2. 2 minus 1 is equal to how much? -1 whole to the power of 1 is equal to -1. And n is equal to 3. Substituting in the place of n minus 1, we will get +1. Okay. And n is equal to 4. We will get to here n is equal to 2 completed. N is equal to 3 completed. N is equal to 4. 4 minus 1 means it will give negative value. -1. Okay. +1 -1 +1 -1 +1 -1. Okay. It can be written as a sequence, alternating sequence. Sequence. Plus is coming, next minus is coming. Alternating sequence. This name is called. Okay. And ఇది కూడా అర్థం కాలేదు అనుకోండి. అంటే సీక్వెన్స్ అనేది మనం ఫస్ట్ ఏం చేస్తున్నాము? xn is equal to n అని చెప్పేసి ఎక్స్పాండ్ చేస్తున్నాం. తర్వాత ఎక్స్పాండ్ చేసిన దాన్ని ఒక దగ్గర రాస్తున్నాం, సీక్వెన్స్ లాగా రాస్తున్నాం. అంటే పైన ఎగ్జాంపుల్ ఏమో ఎక్స్పాన్షన్, 3.2.4 అనేది ఎక్స్పాన్షన్, 3.2.5 అనేది ఎక్స్పాన్షన్ ఉన్నదాన్ని చిన్నగా రాస్తున్నాం, సీక్వెన్స్ లో రాస్తున్నాం. ఇది అర్థం చేసుకోవాలన్నమాట. ఓకే, 3.2.7 అనేది ఏంటి చూడండి. Here xn is equal to -1 whole power n by n. Okay, xn is equal to how much here? Plus 1 by n. Next one, xn is equal to how much? -1 by n. Why? Because substituting n means a natural number. Substituting natural numbers, we will get n is even and n is odd numbers. n అనేది ఈవెన్ నెంబర్స్ వస్తుంటాయి, n అనేది ఆడ్ నెంబర్స్ వస్తుంటాయి. ఆడ్ నెంబర్స్ వచ్చినప్పుడు మైనస్ వస్తుంది, ఈవెన్ నెంబర్స్ వచ్చినప్పుడు మనకు ప్లస్ వాల్యూస్ రావడం జరుగుతుంది. దిస్ ఈస్ ద 3.2.7 ఎగ్జాంపుల్. ఓకే, నెక్స్ట్ వన్ ఫిబోనాకీ సీక్వెన్స్. ఓకే, Fibonacci sequence is introduced by Fibonacci scientists in 17th century. Okay, it is the experiment of rabbits. It is the experiment of rabbits. First of all, the two rabbits are taken. After 1 month, the kiddies, how many kids are there? 2 kids are there. And next month having 3 kids, and next month having 5 kids, and next month having 8 kids, and next month having 13 kids. It is a research is conducted by Fibonacci and rabbits. Okay, he get a Fibonacci sequence, that is x1 is equal to 1 and x2 is equal to 1. The Fibonacci sequence in is xn is equal to how much it is? Xn minus 2 plus xn minus 1 for n greater than 2. Why? Because 2 rabbits are taken. At a time, how many rabbits are taken? N greater than 2. Okay, 2 or more than 2 rabbits are taken. Therefore, xn is equal to how much here? Xn minus 2 plus xn minus 1. We will get a Fibonacci sequence. The name is Fibonacci sequence. 1, 1, 2, 3, 5, 8, 13. It is generated by a shortcut is xn is equal to how much it is? Xn minus 2 plus xn minus 1 for n greater than 2. This is the 3.2.8 example, page number 36. Okay, and the next one, a definition of bounded. Okay, next page I am opening. Here any doubts? Here any doubts? No doubts here? Okay. Now I am opening next page. I'm opening bounded page here. The definition is very, very important in this one. If the range of a sequence an is bounded below, then the sequence, if the range of a sequence an is bounded below, then the sequence an is said to be bounded below. Okay, the definition. If the range of the sequence, range means, here suppose it is n is the natural numbers and r is the real numbers. This is the domain. Okay, this is the range. Okay, a sequence S mapping n to r. Okay, now r is the range. R is the range. If the range of a sequence an is a function name. An is bounded below. Bounded below means bounds are below bounds. Okay, now bounded below. Then the sequence an is said to be bounded below. Okay, I will explain taking a example in next image. నెక్స్ట్ ఇమేజ్ లో నేను దీని గురించి క్లియర్ గా ఎక్స్ప్లెయిన్ చేస్తాను. ఇక్కడ మీరు చూడండి, ఇక్కడ range bounded below means sequence of an is bounded below, the sequence is called bounded below. Suppose the range of a sequence an is bounded above, to take the sequence is bounded above. A sequence is said to be bounded if it is both bounded above and bounded below. Bounded means bounded above and bounded below. A sequence an is bounded if there exists a finite number of small n and capital M such that Small m is left side, less than or is equal to sequence xn, less than or is equal to capital M. Capital M is the upper bound, small m is the lower bound. Okay. For every natural number small, n is belongs to capital N. If the sequence xn is bounded above, we will get a least of the upper bounds. Is called the LUB, least upper bound. If the sequence xn is bounded below, we will get greatest of the lower bounds. We will get the greatest of the lower bound. Okay. We can take a example, two examples. I will take two examples and I will explain this one. Bounded below is what? Bounded above is what? Bounded means what? Least upper bound means what? Greatest lower bound means what? Okay. In next page. Okay. This is all definitions. This is all what here? Definitions. This is all definitions. Okay. Here I'm taking example. Okay. Here. Here 3.1.0. Here sequence xn. To take sequence xn here xn is equal to how much here? 1 by n. Okay. Here xn is equal to, we are substituting the numbers. We are substituting the numbers here. N is equal to comma n is how much it is? Xn is equal to 1 by 1 comma 1 by 2 comma here how much it is? 1 comma here 1 comma 0.5 comma 0.3 comma 0.25 comma 0.2 and so on. We will get how much it is? We will get how much it is? 0.00001. Okay, last one. Okay, here 1 is the upper bound and next one we have no 0 but 0. Okay, the sequence is here the in this example here, okay, here we can take here some internet connection. Okay. Okay, I will explain here. Here in this example, here small m and capital M is not there. Here small m is the lower bound is not there, capital M is upper bound is not there. Only here one is the comparing. Here to take here I am opening a image. I'm opening an image. Wait. I'm opening a image. X is equal to 1 by n. Okay, here x is equal to 1 by n. Okay, here x is equal to here 1 by n graph. X is equal to 1 by n or x is equal to 1 by x is there. Here see here. X is equal to 1 by x. Here x is tends to x is approaching to infinity is equal to 0. We will get here. How much it is? We are substituting here. Here highest point is here 1 and the lowest point is how much it is? Here it is going, not touching the x-axis. This is the x-axis. This is the x-axis. This is the y-axis to take here. And the x-axis we are taking natural numbers, and the y-axis we are taking real numbers. Okay, x-axis మీద natural number తీసుకుంటున్నాం, y-axis మీద real numbers మనం ఈ విధంగా తీసుకుంటున్నాము. తర్వాత నెక్స్ట్ substituting 1 by n, substituting here 1 by n, here 1 by n, n values we are substituting here. What we will get here 1 by 1. 1 by 1 means 1. 1 by 1 means here. This one. And substituting x is equal to here 1 by 2. Here how much it is? 1 by 2 is equal to how much? 0.5. And n is equal to 3. 1 by 3 is equal to how much? 0.33. Here next one, x is equal to 4. We will how much we will get here? 0.25. 1 by 4. 1 by 4 means 0.25. X is equal to 5 means 0.2. 1 by 5 means 0.2. And x is equal to 6 means 1 by 6 means 0.166. Here x is equal to 7. Okay, x is equal to 10 means 0.1. X is equal to 20 means 1 by 20. 1 by 20 means how much it is? We will get how much? X is equal to 1 by 100. How much we will get? 0.01. Suppose x is equal to 1 by 1000. How much it is get? 0.001. Okay. It is going like decreasing order. It is a decreasing range. Decreasing range. It is not an increasing range. It is a decreasing range. 1 దగ్గర నుంచి వెళ్ళి 0కు దగ్గరికి వస్తుంది కానీ 0 రావట్లేదు. 0 అనేది మనకు రావట్లేదు. అంటే ఇక్కడ కంపేర్ చేయాలి. వి మస్ట్ హియర్ కంపేర్ చేస్తే మనకు ఏమొస్తుంది ఇక్కడ? మనకు చూడండి ఇక్కడ వి మస్ట్ కంపేర్ 1 ను ఇక్కడ 0.5 తో కంపేర్ చేస్తాం అనుకోండి. ఏమొస్తుంది ఇక్కడ? అప్పర్ బౌండ్ వస్తుందా, లోవర్ బౌండ్ వస్తుందా? బౌండెడ్ ఎబోనా, బౌండెడ్ బిలోనా? అప్పర్ బౌండ్. హియర్ 1 ఈజ్ ద అప్పర్ బౌండ్. 1 అనేది 0.5 తో మనం కంపేర్ చేస్తున్నాం. నెక్స్ట్ 0.25 అనేది 0.5 తో కంపేర్ చేస్తున్నాం. 0.5 అనేది 3 తో కంపేర్ చేస్తున్నాం. నెక్స్ట్ 0.3 ని 0.1 తో కంపేర్ చేస్తున్నాం. ఈ విధంగా మనం కంపేర్ చేసుకుంటూ వెళ్తున్నాం. అంటే డిక్రీజింగ్ ఆర్డర్ లో మనం వెళ్తున్నాం. అంటే ఇక్కడ మనం ఏమని చెప్పొచ్చు? ఇక్కడ ద సీక్వెన్స్ ఈజ్ బౌండెడ్ అబోవ్. ద సీక్వెన్స్ ఈజ్ బౌండెడ్ అబోవ్. అండ్ 1 ఈజ్ ద లీస్ట్ అప్పర్ బౌండ్. అప్పర్ బౌండ్ లో 1 అనేది ఏమవుతుంది? లీస్ట్ అప్పర్ బౌండ్ అనేది మనకు రావడం జరుగుతుంది. అండ్ నెక్స్ట్ వన్ హియర్ మనకు ఈ ఆన్సర్ ఎక్కడికి వస్తుంది? 0 దగ్గరకు వస్తుంది కనుక మనం అక్కడ కంపేర్ చేసాం అనుకోండి. 0 దగ్గర కంపేర్ చేస్తే లోయెస్ట్ బౌండ్ 0 ఇస్ ద లోయెస్ట్ బౌండ్. దీంట్లో ఈ లోయెస్ట్ బౌండ్ లో లోవర్ బౌండ్ లో మనం ఏం తీసుకుంటున్నాం? గ్రేటెస్ట్ లోవర్ బౌండ్ తీసుకుంటున్నాం. గ్రేటెస్ట్ లోవర్ బౌండ్ ఈజ్ 0 హియర్. ఓకే, లోయెస్ట్ అప్పర్ బౌండ్ ఈజ్ 1. కంపేర్ చేస్తూ ఉన్నాం. కంపేర్ చేస్తూ ఉంటే మనకు అప్పర్ బౌండ్లో లీస్ట్ అప్పర్ బౌండ్ ఎంత దొరికింది? మనకు 1. తర్వాత లోవర్ బౌండ్లో గ్రేటెస్ట్ లోవర్ బౌండ్ ఎంత దొరికింది? మనకు 0 అనేది మనకు రావడం జరుగుతుంది బై దిస్ డయాగ్రామ్. ఓకే, నెక్స్ట్ వన్. ఇది అర్థం కాలేదనుకోండి, ఇంకొక ఇమేజ్ తీసుకుంటున్నాను. ఇదైనా అర్థమవుతుందని నేను అనుకుంటాను మీకు. నెక్స్ట్ ఇమేజ్ తీసుకున్నాం. నెక్స్ట్ ఎగ్జాంపుల్. తీసుకున్నాం. చూడండి ఇక్కడ 3.2.11. ఈ ఎగ్జాంపుల్ ఈజీగా మీకు అండర్స్టాండ్ అవుతుంది. చూడండి 3.2.11. ఫర్ ద సీక్వెన్స్ xn is equal how much? -1 whole power n by n. రెండు తీసుకున్నాం ఇక్కడ. -1 whole power n by n. ఇక్కడ n వాల్యూస్ సబ్స్టిట్యూట్ చేసుకుంటూ వెళ్తున్నాం అనుకో. -1/1, తర్వాత 1/2, నెక్స్ట్ -1/3. n వాల్యూ అనేది సబ్స్టిట్యూట్ చేసుకుంటున్నాం. n is equal to 1 అయితే n is equal to 1, it implies to -1/1. n is equal to 2 అయితే మనకు -1 whole square by 2. We will get how much? 1/2. n is equal to 3, we will get how much? -1/3. n is equal to 4, we will get 1/4. n is equal to 5, -1/5. n is equal to 6, 1/6. ఈ విధంగా మనకు రావడం జరుగుతాయి. ఓకేనా? నెక్స్ట్ వన్, మనకి ఇక్కడ 2 టైప్స్ ఆఫ్ నెంబర్స్ వచ్చాయి. ఒకటేమో డిక్రీజింగ్ నెంబర్ సిస్టమ్, నెక్స్ట్ డిక్రీజింగ్ నెంబర్స్ వచ్చాయి, ఇంకోటి ఇంక్రీజింగ్ నెంబర్స్ వచ్చాయి. ఈజీగా మనకు అర్థం కావడం కోసం. ఓకేనా? అవి ఇక్కడ రాస్తున్నాను చూడండి. ఇక్కడ -1 0.5 కామా -0.3 కామా 0.25 కామా -0.2 కామా 0.16 and so on. Okay. Therefore we can take here increasing order numbers, decreasing order numbers same 0.5 comma 0.25 comma 0.16. Increasing order -1 comma 0.3 comma 0.2 and so on. Okay. Here the bounds are there. మనకి బౌండ్స్ అనేటివి ఉంది. లోవర్ బౌండ్స్ ఉన్నాయి, అప్పర్ బౌండ్స్ అనేటివి ఉన్నాయి. ఇక్కడ డిక్రీజింగ్ ఆర్డర్ లో ఉన్న బౌండ్స్ ఉన్నాయి, ఇంక్రీజింగ్ ఆర్డర్ లో ఉన్న బౌండ్స్ ఉన్నాయి. ఇక్కడ చూడండి, ఇక్కడ యూబీ మీన్స్ అప్పర్ బౌండ్స్. యూబీ మీన్స్ హియర్ అప్పర్ బౌండ్. అప్పర్ బౌండ్స్ ఇస్ ఈక్వల్ హౌ మచ్ హియర్? అప్పర్ బౌండ్స్ ఏమేమి ఉన్నాయి ఇక్కడ? 0.5 కామా 0.25 కామా 0.16 అండ్ సో ఆన్. 0.5 కామా 0.25 కామా 0.16. దిస్ ఇస్ ద అప్పర్ బౌండ్స్ ఉన్నాయి. నెక్స్ట్ లోవర్ బౌండ్స్ ఏమేమి ఉన్నాయి ఇక్కడ? -1 కామా -0.3 కామా -0.2. దిస్ ఈస్ ద లోవర్ బౌండ్స్. దిస్ ఈస్ ద లోవర్ బౌండ్స్. లోవర్ బౌండ్స్ ఉన్నాయి. ఇక్కడ మనకు అప్పర్ బౌండ్స్ అనేవి ఉన్నాయి. దీంట్లో అప్పర్ బౌండ్స్ లో మనం ఏం చేస్తున్నాం? అప్పర్ బౌండ్ లోవర్ బౌండ్ రెండు అయ్యాయి అనుకోండి, దాన్ని ఏమంటాం? బౌండెడ్. దాన్ని ఏమంటాం మనం? బౌండెడ్ అని అంటాం. ఇక్కడ మనకు 2 టైప్స్ ఆఫ్ నెంబర్స్ ఉన్నాయి ఇక్కడ. కానీ ఇది బౌండెడ్ అవుతుందా? బౌండెడ్ అవుతుందా? ఇక్కడ మనకు 2 టైప్స్ ఆఫ్ నెంబర్స్ వస్తుంది. అంటే బౌండెడ్ కావడానికి మాత్రమే ఛాన్స్ ఉంది, కానీ ఇది సీక్వెన్స్ అనేది కాదు. సీక్వెన్స్ మస్ట్ బి హ్యావింగ్ ఓన్లీ 1 లిమిట్ పాయింట్ అనేది మనకు కావాలి. ఇట్ ఈస్ బౌండెడ్. బౌండెడ్ మాత్రమే ఇది వస్తుంది, సీక్వెన్స్ అనేది కాదు. ఇక్కడ లీస్ట్ అప్పర్ బౌండ్. అప్పర్ బౌండ్ లో లీస్ట్ వాల్యూ ఎంత? 0.5. 0.5 అనేది మనకు లీస్ట్ అప్పర్ బౌండ్. ఇస్ ఈక్వల్ హౌ మచ్ ఇట్ ఈస్? ఇట్ విల్ గివ్స్ వాట్ హియర్? 1/2. And next one, lower bounds lo greatest lower bound is how much it is? -1. Okay, -1. Next, any doubts in this section? All of you, ఏమైనా డౌట్స్ ఉన్నాయమ్మా?
నో డౌట్స్ సార్.
ఏమైనా డౌట్స్ ఉంటే అడగొచ్చు. Okay, thank you all of you.